Lesson 8-7, Linear Inequalities, Part 1. All right, little review. So we have learned how to solve a one-variable equation, something like 2x equals 6. We divide by 2, x equals 3. There's one solution. Then we learned how to do a one-variable inequality. This could be the same thing that we just did, however, let's say 2x is less than 6. Solving for x, we know that there, with an inequality, we can have a lot of solutions. So if I divide by 2, x could be anything less than 3. And to show all of those solutions, we graphed on a number line. 0, 3, open circle to the left. So one solution, many solutions. All right, then we very recently learned how to graph a two-variable equation. So 2x plus 1 equals 9. Oh, sorry. Nope, that's a two-step. Erase. Two-variable meaning there are two variables. So y equals 2x plus 4. We know how to graph this because there are multiple xy solutions. So we know how to graph the line with our y-intercept and our slope. Well, today we're going to talk about two-variable inequalities, something like y is greater than 2x plus 4. We're going to talk about how to graph all of those solutions. So all that changes with a linear inequality is the equal sign in an equation is replaced with an inequality symbol. So now, instead of just graphing a line and those being the solutions, we can have anything less or greater than those solutions. So with inequalities, we're going to be shading some regions. Let me show you what I mean. All right, so in example 1, A, when you see an inequality, y is less than or equal to x plus 2, you're going to graph the boundary line. This is the boundary line for all solutions have to be either greater or less than our line. When you do it, you want to pretend it's an equation. I'm going to make this inequality symbol an equal sign for right now. We know how to graph y equals x plus 2. I go to my y-intercept of 2. My slope is 1. I plot all my points. And I make my line. Okay. Now, here's the important part to learn. If you have an inequality with a greater than or equal to or less than or equal to symbol, you are going to make a solid line. When you have an inequality and it has a greater than or less than symbol, so no equal to, you are going to make a dotted line for your graph. This is going to be hard to remember, but it's really important. We do this because if our answer was y is greater than x plus 6, the xy coordinates on this line aren't solutions because there's no equal to. So that's why we do a dotted line. In this, with an equal to symbol, if we had y is greater than or equal to x plus 6, the ordered pairs on this line could be solutions because of the equal to. So just remember, these symbols, solid line. These symbols, dotted line. Make sure you get that down in your notes. All right, so going back to our graph. So because this was, I'll erase it here because I covered it up. Because this was a greater than or equal to symbol, I made a solid line. All right, so first graph your boundary line. Second, decide if it's dotted or solid. Now third, we need to show that y can be anything less than or equal to x plus 2. Well, does that mean we shade down here or do we shade up top? That's the question. So you need to pick a point that isn't on this line. The easiest point to pick is 0, 0. So if your line doesn't go through 0, 0, you can use it. So most often it doesn't. So I'm going to use 0, 0, and I'm going to test it in my inequality. So for y I'm going to put a 0, and for x I'm going to put a 0. Let's see if 0, 0 makes this inequality true. 0 is less than or equal to, well, 0 plus 2 is 2. Is 0 less than or equal to 2? Yes. So that means that the side of my line where 0 is, these are all solutions, so I shade underneath my line. Let's check the book's answer. Here's their line, solid, and they shaded everything underneath. They put 0, 0 in and realized that 0, 0 is a possible solution. All right, let's do another example. So let's look at B. Y is less than negative 2x. I'm going to look at this as y equals negative 2x. I can graph that. The plus b is plus 0 since there's nothing there. So this one goes through the origin. My slope is negative 2, down 2 over 1, down 2 over 1. More points this way. I'm going to go up 2 over 1. And then I'm going to get an arrow. Now, because this is a less than sign, I need to make a dotted or dashed line. So in example A it was solid, example B it's going to be dashed. Now I can draw in my arrows. Now I need to shade. I can't use 0, 0 as a point because that's part of this line. So I need to pick a point that isn't. I'm going to pick 1, 1 because that point is right here. So if I put 1 in for y and 1 in for x, I get 1 is less than negative 2. Well, that's not true because 1 is actually bigger than negative 2. That means that that point was not a solution, so I'm not shading that side. I'm going to shade everything on the opposite side of the point I tested. Let's check the book. There's their dotted line, and they shaded everything to the left. Looks like they picked the same point as we did, and it was not a solution. It was false. Alright, so I'll do one more example for you to watch. I'm going to do y is greater than or equal to 3x minus 1. I'm going to look at it as y equals 3x minus 1, so you're practicing your graphing. Y-intercept of negative 1, this graph is very small. My slope of up 3 over 1. Now I'm going to have to guess because this graph is so tiny. Because it is a greater than or equal to sign, I'm using a solid line for my graph. I'm going to try my best. Just like that. Now I need to test a point. 0, 0 was not a solution, so I can use that. So I'm going to put 0 in for x and y. 0, where I see an x, I'm putting a 0. So I have 0. Oh, I need my inequality sign, not equals. Greater than or equal to, these should have been greater than or equal to. 3 times 0 is 0 minus 1. Is 0 bigger than negative 1? Yes, yes it is. That is true. So that means that I'm going to shade the side that 0, 0 was on. And there we have it. Our last example is writing our own linear inequality for a word problem. So, in the photo, there's a farmer's market. Suppose you want to buy apricots and tomatoes. You plan to spend no more than $10. How many pounds of each can you buy? Well, we're going to have x be our number of apricots and y be our pounds of tomatoes. So, we don't know how many of x, or apricots, and we don't know how many of tomatoes, but all we know is that our pounds is no more than $10. So I need an inequality symbol. X plus y, when I add together my pounds of apricots and tomatoes, they need to be less than or equal to $10 because I can't go over. So here's my inequality. Now I can graph because there's lots of possibilities of pounds for apricots and tomatoes. I could do one of each. I could do two of each maybe. So let's see. I'm going to graph all of those solutions. I first need this to be y equals. So I'm going to subtract x from both sides. So I have y less than or equal to negative x plus 10. Here's my inequality. I'm going to make an equation just for graphing purposes. Y-intercept of 10, slope of negative 1. It's a less than or equal to 2 sign, so I'm going to make a solid line. There it is. Now, where do I shade? Well, 0, 0 isn't on my line, so let's use that point. If I have, I'm going to go back to my original equation. X plus y is less than or equal to 10. If I put 0, 0 in for y, is 0 less than 10? Yes, it is. So I'm shading everything underneath my line. Oops, I went a little bit over. Go back with my eraser and just erase that. There. So that means any point under in this yellow region, my X was my apricots and my Y was my tomatoes. Any point will give me possible numbers of apricots and tomatoes that I can buy at the market. For example, if I pick this point, that's over 2, so I can get 2 pounds of apricots, and it's up 3, and I can get 3 pounds of tomatoes, and I will be under my 10-pound limit. Alright, so here's your lesson check, just 2 problems. In the first problem, they want to know if the ordered pair 3, 0 is a solution. So plug 3 in for x and 0 in for y and see if it makes it true or false. In number 2, you're going to use a graph to graph this inequality. Remember to first graph the y equals mx plus b, then decide if you need a dotted or solid line, then pick a point so that you know which side of the line to shade. Good luck!